Good day, everyone, and welcome to our webinar, Advancing 6G with millimeter wave testbeds, RIS, and phased arrays. My name is Michael Abdallah. I am an engineering professional with over than 15 years of experience in the research, product development, and industrial consultancy, specialized in communication technology within the commercial and military use. Throughout my career, I have worked as a senior manager and communication application research sector leader at Saab RDS, and I have successfully led and contributed to a wide range of application, from basic to advanced technology projects across the region, supporting strategic initiatives in research, education, and high-tech product development. My current expertise spans from system design and technology integration to cross-sector collaboration with a strong focus on enabling cutting-edge communication capabilities for national and regional stakeholders. Today, and within the same vision of innovation excellence delivered at speed, we are here with our partner TMY Tech to talk about advancing 6G with millimeter wave testbeds, RIS, and phased arrays for defense. We have with us Mr. Ethan Lin. He's the co-founder and VP of TMY Tech, a global leader in millimeter wave phased array antenna solution. He has founded 3 companies since 2007, and he leads software, product, and marketing teams. At TMY Tech, he drives innovation in millimeter wave phased array antenna solutions for mobile, satellite, automotive, and defense sector. Previously, he founded Scarlet Tech and worked at HTC, collaborating with Microsoft and Qualcomm on smartphone products. He also contributing to building the world's largest infrared telescope and holds a master's in electronics engineering from NCTU. So the agenda of today will start with a brief introduction about Saab RDS and our 6G innovation solutions. We will move then to our partner TMY Tech, who will be talking about solutions for 6G. Then we will end up with demo and the Q&A session. So feel free to write down your question in the chat box during the session so we can answer them all at the end. So who we are Saab RDS. We are devoted to empowering businesses with innovative technologies. We act as a boutique for technology engineering. We source, we tailor, and deploy latest technologies to drive innovations in Saudi Arabia. So at Saab RDS, our mission is to bring the most advanced technologies from around the world and adapt them to the local environment. By doing so, we help drive innovation and we enable the local leaders to shape the future of mobility in the kingdom. Our strengths lies in blending smart technologies such as AI, IoT, and machine learning with our engineering expertise to create solutions that are not only cutting edge, but also practical and impactful. As a good example of our expertise is software-defined radios, where we bring together the latest technologies in wireless communication with our engineering expertise to push the boundaries of connectivity. Our goal is to ensure that communication are not only faster and more advanced, but also secure and interoperable, enabling an interconnected world where systems, industries, and people can all work together. Our software-defined radio solutions are designed with advanced multi-channel capability, enabling both transmit and receive operation across a wide spectrum. They support modern applications like MIMO, ensuring high performance in complex environments communication systems. The architecture is flexible and open, making it suitable for integration with various sensors and adapt for wideband radar and electronic warfare applications. In addition, these systems offer broad software compatibility, from open source to C languages to LabVIEW and MATLAB. This will give the developers the freedom to innovate across different platforms, whether for compact handheld device or large-scale, high-capacity systems where the solution is built to scale and deliver robust performance. So at Saab RDS, we follow a complete product life cycle model to deliver innovation that starts and ends with the end user. Our approach begins with deep research and development of concepts, ensuring alignment with customer needs. Then we move into design and engineering, where ideas are translated into practical high-performance solutions. Then we will move to prototyping and testing. This will allow us to validate functionality and reliability at early stage. This will reduce the risk and optimize the performance and accelerate time to market. Following to the prototyping and testing, it is followed by the validation, which will transition automatically to production and implementation, where we leverage advanced processes to ensure scalable and consistent quality outputs. Our frameworks extend into deployment and market integration, enabling real-world adoption of solutions. This will ensure that technologies are not only delivered, but also fully embedded into customer operation. Finally, we focus on continuous improvement, adapting solutions as market and customer needs evolve. We have a long story of bringing experience or engineering excellence to the academic research world. We have established advanced research facilities that drive both economic growth and social development. Our role is to act as a bridge between scientific discovery and practical engineering, turning ideas into real-world applications. By empowering researchers, we provide the tools and expertise needed to transform concepts into functional prototypes, where these prototypes are designed with scalability in mind, ensuring they can evolve into full-scale solutions that can create lasting impact. Specifically, I would like to talk, and in this webinar, we are talking about wireless communication research, where we focus on advanced next-generation technologies that shape the future of connectivity. We explore massive MIMO system, enabling higher capacity and improved reliability in complex network environments. Using software-defined radio and USRP platforms, we provide flexible and reconfigurable test beds for experimentation, allowing rapid prototyping and validation of 5G and 6G application. Together, these efforts can create a comprehensive foundation for innovation in advanced systems. So the future of wireless communications is centered on connecting everyone and everything in an intelligent ecosystem. As 5G continue to expand its capabilities and 6G emerge, network will move into higher frequencies, including the low terahertz range. This evolution will be powered by phase array antenna technology, broader bandwidths, and higher modulation densities. Such advancement will unlock entirely new use cases, from massive machine-to-machine communication to ultra-reliable, low-latency applications. So at Saab RDS, we are committed to supporting research leaders like yourself to unlock the full potential of 5G and 6G communication, beamforming, and millimeter wave propagation technologies. A clear example is our 6G massive MIMO testbed, which provides a flexible and cost-effective platform for advanced wireless communication research, designed to handle high data rates and real-time interaction with billions of connected devices. The system integrates with OFDM modulation, remote radio heads, CPUs, and FPGA, offering a complete out-of-the-box solution. It delivers full streaming, real-time, phase-coherent, and time-synchronized multi-channel performance. With a broad frequency coverage and support for multiple modulation schemes, the testbed is ideal for both uplink and downlink studies. It enables users and multiple users to implement massive MIMO experiments with high stability and full synchronization across all RF channels. So at the end of this introduction, why Saab RDS? Saab RDS deliver agile and reliable technologies tailored to today's need and ready to scale for tomorrow. And we do partner with a innovation partners of our network of innovation partners, such as TMY Tech here today with us, allowing us to combine engineering expertise with the latest and most innovative solutions to provide fast, dependable, and future-ready solutions. So before we move the mic to TMY Tech, I will today in this session with TMY Tech, we will discover how the solution of TMY Tech are scalable, like FR2, FR3 testbeds, and phase array solution are integrating with an IUSRP for seamless phase coherent prototyping. Also in today's session, we will discover how dynamic reconfigurable intelligent surfaces, RIS, are enabling adaptive beam steering and extended coverage. Also, we will discover today how emerging 6G technologies are driving use cases such as NTN, ISAC, JCAS, massive MIMO, SATCOM, radar sensing, and V2X. So I will give now the mic to Mr. Ethan. So the mic is yours, so you can start. Thank you.
All right. Thank you, Michael. So first, I truly thank you, Michael and Saab RDS, one of our great local partner. So definitely, we have a great complementary strength to each other. Thank you for having me today. My topic is about advancing 6G with a millimeter wave testbed, RIS technology, and a phase array. My name is Ethan Lin, the co-founder and SVP of TMY a millimeter wave company. So first, today's webinar, let's explore something together. First, you will find out how we can accelerate your research, advanced research, with a ready-to-use FR2, FR3 open source testbed for rapid RIS or RAN prototyping. Second, you will explore a solution, empower your teaching with a complete millimeter wave or NTN lab kit that bridges theory and practice. And you will learn 6G trend, including FR3, RIS, software-defined phase array in TMY Tech. So first, why? So why we need more or better network, more throughput? Because AI is coming, it's changing the world. So AI is bringing new data traffic. So new data traffic requests more mobile network. To provide you a background, by 2033, 1/3 of data traffic are coming from AI. So it's more than 1,000 exabytes per month is predicted in the near future. So what exabyte mean? Exabyte is a million gigabyte. Okay, so you can imagine how huge of amount of data will be exchanged over the mobile network. So this is really a new motivation for people to develop a better network. Another big trend is, okay, the growth of mobile traffic never stops. It's unstoppable. From now to 2030, as you can see from the chart, it grows exponentially, right? So use US mobile data traffic as a great example. From 2021 to 2023, just within 2 years, the data traffic doubled. The mobile data traffic doubled. So it is very predictable, right? By 2029, it will triple again. So data traffic growth never stop. We need a network. We need something better to support the infrastructure of our network. Okay, so 6G. Here is 6G promise a greater future. Fulfill the scenario and all the demanding of the network, no matter it's coming from AI or from other hot applications like AR, VR. 6G promise the future. Here is a great example to show you how people can combine different spectrum to fulfill different scenario and create an ubiquitous network environment. This is Taipei City in a crowded area. We need a capacity band. The central part, that means we need a high band TDD, which is a millimeter wave. Okay, so in the second circle, in wide area, what do we need? We need a capacity band. So capacity band would benefit by either capacity or the coverage. So 6G, people is gonna define the new spectrum, we call it FR3, to fulfill this wide area capacity band. So sometimes people call it the upper mid band, which is the spectrum is created to fulfill the purpose of this area. And next, in the third circle, we need a coverage band. Okay, so in rural area, some people probably only request the minimum connectivity. So coverage band offer certain good enough data rate which is acceptable. So different spectrum are going to used in different area. Okay, so in 6G, more than that, satellite. So satellite communication is coming to the game. It definitely will fulfill the final puzzle for all the rural area or even on the sea, right? So literally, we're going to have a ubiquitous network in the future, very near future. This is how that 6G network looks like. From satellite orbit, geostationary Earth orbit, and middle Earth orbit or low Earth orbit, right? Geo, MEO, LEO, those are very hot keyword to this word because now people are shooting more and more satellite to provide a better and higher density of network. So this satellite network works seamlessly with the mobile network located at the ground station or the ground segment. So this is so-called NTN, non-terrestrial network, should work perfectly seamlessly with the terrestrial network. And more important is now, since from 5G advance, 3GPP start to expand the standard up to satellite communication. Okay, so one standard applies to all orbit and all layers of communication. So as you can imagine, how much a great application can be in the future. Let's talk about a mmWave. That's where TMI-Tech are good at. So certainly mmWave technology promising so many amazing future applications, including autonomous driving, including remote surgery, a better defense system, precision agriculture, augmented reality, and many so on. So that's really the fundamental infrastructure for so many great future applications. And that's what we are good at. All right, so TMI-Tech, we are a mmWave company founded back in 2014 by Sue and myself. Nowadays, we have almost 100 employees. More than half of our employees are engineers. Fundraising, we have a pretty good fundraising record in Taiwan, and now we are listed at the Taiwan Stock Exchange since this January. We are planning to shoot for IPO next year, right? So our headquarters is in Taipei. We have R&D center in Hsinchu. We have US and Japan offices. We're holding more than 100 global patents, so we are really a technology company. We have a very strong R&D energy and resources. Of course, we partner with the global tier 1 tech leaders as well. So let's look at what we are offering today. We have basically two groups of product portfolio. The first group we call the mmWave instrument. So those instruments can definitely help you to build up the prototype you need for your wireless research. Right, it's ready to use. All these devices are ready to use. So you build your network test bed with no effort. Another portfolio, we offer design services to customize a mmWave phase array to fulfill your applications, no matter it's aerospace or satellite communications or 5G or 6G. We talk about it more later. Okay, so let's look at our 6G solutions. First, we offer great testbed. So that this super flexible testbed is not good, only good for 5G, but also 6G. FR2, FR3 ready, beamforming, right? So you'll be benefited by beamforming features with no effort. Just plug and play. So imagine how easy it is can be benefit to your research. SDR and open source integration. As Michael mentioned, SAP is a company, they have a great expertise in software-defined radio. And our device really complement to SDR. Okay, so combined with SDR, the real powerful testbed was formed. Next, we offered that the device so-called RIS. RIS stands for Reconfigurable Intelligence Services, which is a super hot topic for wireless research now, and we commercialized it already. We have antenna in package technology. That's the foundation of our phase array. So we provide a 5G phase array, SATCOM phase array, and even 60 gigahertz radar phase array. All right, now let's explore test. That's the first thing that TMYtech can help you in your research. So first, look at the photo here. This is a really super flexible FR3 scalable testbed for 6G, 5G and 6G research for defense, for SATCOM. Okay, so this is SDR. It shows that there are 8 channels, right? So with 44R, it's a great platform to have a research like a MIMO and the phase coherency. And the device on top of this SDR is one of our hot piece. We call it a UD box 630. So this device extends the SDR in step to enable SDR to mmWave band. With a combination of a UD box and SDR, definitely you can no longer just do a simulation, right? You can record the real life data and then to monitor and to send over data over the high band, the mmWave band. So there are so many detailed data. I will leave it here, so in the future you can read it out. But my point is, this is a great combination for defense application. Okay, like a radar and electronic warfare research, and of course this can be used for SATCOM, ground terminal, and payload emulators, and many so on. So this is a great platform. So this FR3 testbed, let me give you a further more detailed look into this the architecture of this testbed. So you have SDR here. This is frequency extender provided by TMYtech. In FR3, we offer home antenna, one for TX, one for RX. Okay, so another set for receiver side, we have the same setup. So combined with the SDR, the application in SDR, you literally can do your research, spectrum regulator, any 6G innovations, and many so on. So there's no limitation because we prove the integration between RF and the SDR. So then you can play the whole setup as you want. We do the job for you, integration job for you. You can just plug and play and put your innovation, turn your innovation into the software of SDR, and boom, you just go. Okay, just like simple like that. Okay, so those testbed I'd like to give you a quick taste about what a testbed looks like. And then next, I like to introduce RIS. Stands for Reconfigurable Intelligence Service. The main purpose of this intelligence service, or we call it smart mirror, is good for deploying, right? To extend the coverage, and so this is essentially important for deployment. As you may see here, what if we have an L-shaped room and we only have one base station? All right, there's no answer before because there's no way you can transmit or you can, extend the coverage to cope with the L-shaped room. However, with a reflector, especially with a reconfigurable reflector, you can reflect the signal and to fulfill the gap. So no more blue signal. So that's the main purpose of this device. Today, we provide We provide a 3.5, 4.7, and 28 gigahertz. We offer 3 bands, so 3 different models to cover different bands. All right. So if you are interested in how this device can help in your research, yeah, you can find out it from more detail from our website, of course. But here is a highlight features of our RIS. The first is super stable. As you can see, the first animation on the left side, freely you can combine up to 4 RIS to form a larger array. Okay, so that really offers a great flexibility to your research. So this is number 1 great highlight feature I'd like to show you. So here is a short video. I'd like to show you how this scalable tie-lab array is being measured.
As we move towards 6G, dynamic RIS is redefining how signals travel. With active control, each RIS element can precisely reflect, steer, or focus mmWave signals. Let's take a closer look. We set up a typical L-shaped corner reflection scenario. At the transmitter side, BBox 1 sends RF signals. The UD-Box 5G handles up conversion to mmWave, while the NIPXI VST system generates the signal. The signal hits the RIS, which is now in a 2x2 array mode, extending both range and coverage. It then reflects toward BBox light, down converted again by the UD-Box 5G, and analyzed by the PXI VST. Here, we can clearly see performance through real-time data. With WebTLK, we can combine RIS tiles into larger arrays based on distance and easily adjust the reflection angle. Now we switch to a 1x2 array. This shows how different setups impact signal behavior and how flexible dynamic RIS can be. RIS offers hybrid band advantages, enabling seamless switching between FR1 and FR2 band. With just one controller, users can easily reconfigure the system for different frequency ranges. Dynamic RIS unlocks a software-defined environment, enabling more efficient and controllable mmWave communication.
Remember to subscribe, like, and ring the bell.
Okay, super cool. When every time I saw this, I think the device is cool. So next, I'd like to show you FR2 testbed. Okay, so let's have a closer look at this our FR2 solution. So this is the mmWave SDR and FR2 OAI for wireless research. As you may see here is a big combination of different devices, including beamformer, including UD-Box, which is frequency extender, and SDR. Of course, there's a control host, right? So, but you don't have to worry about how you can put all pieces together because it's been done. We've done it for you. You can just use the testbed and start program. Here is the architecture of this OAI reference architecture. So core network and GNOB software are run on this black small little tiny PC, but the PC is still very powerful. The IQ signal will be sent over to USRP X14, which is a very super powerful SDR. The signal then will be basically USRP plays the role as a transceiver. That after this ADDA, the signal was converted into an IF signal and send it over to use this frequency extender to up convert the signal to mmWave. Our beamformer will then do the analog beamforming. So it's highly directive signal. So however, when we already put everything together, you are able to just cabling to the cabling and power supply of each devices and turn on the PC. Then you can start play your software stack and test it with the latest technology. So this is a typical base station, open source base station looks like with the beamforming capability. It's super flexible. For UE side, user equipment, we are able to replicate the same setup for USRP, UE, or a COS UE. There's so many different choices. So here is another demo success story that I could share with you. This is the final demonstration.
In this demo, our base station runs the OEI protocol stack on the OEI box from Orbi Smart. The R front-end includes USRP X410 from National Instruments, along with TMY tags, up-down converter, and two 16-element analog beamforming arrays operating at the carrier frequency of 28 GHz. On the UE side, we use the FR2-enabled 3GPP Release 16 compliant Quectel modem with two antenna ports. This configuration allows us to achieve multiplexing of two spatial streams, resulting in a significant increase in throughput compared to a single antenna setup. This marks the world's first open source 5G standalone FR2 MIMO demonstrator, setting a new milestone in the Open Air Interface Software Alliance. With this work, we extend our research capability in the FR2 band, allowing us to exploit larger available bandwidth and explore new opportunities for integrating sensing and communication, or ISAC in short.
Right. Since we have a great testbed, we even further, one step further is we even integrate our RIS into this system. So now, literally, you have a full functional testbed. It's super flexible because it's open source, and you don't have to worry about a mmWave for beamforming. You can just control the beam direction through API or through a GUI tool. No problem. Everything are ready. So the testbed is definitely dedicated for your research. The testbed is good for FR2, FR3 research, RIS, 6G, NTN, ISAC, or JCAS, for ORAN, for AI, ML, and many so on. So this is 28 GHz B-Box 8x8 dual. This new device we are going to roll out by the end of this year. So this is a great device to have dual polarization with the 8x8 elements, offers a great EIRP. So this is a new device. So this new device is definitely great for MIMO research. Of course, it is also a good match to use the device along with the SDR. Okay, so I'd like to walk through some use case for you. So first, we already demonstrated RIS and a beam tracking. As you may see here, when we move beamforming, the RIS will change the incident and reflected angle. The constellation diagram here and the video playback here remains pretty constant. Okay. So RF data recording, that's one of another good example that we implement on an SDR along with our mmWave device. A 4x4 MIMO testbed. Okay, that's the great example to show you how SDR work with our RF front end. So this is new. The device is gonna roll out by the end of this year. So you are interested in mmWave and the MIMO, that's the platform for you. All right. Here's another example: integrated sensing and communication, which is also one of the vision of 6G communication. The signal in mmWave can not only be the carrier for communication, but the high directivity is also offers a good point of source for sensing something, right? So the scientists and engineers start looking into the possibility to combine the sensing and the communication with the same spectrum, right? So this is definitely another layers of the applications in the future. So next, I'd like to show you education kit. In addition to those high-end research grade tools or massive testbed, we offer educational kit to empower your teaching. Yes, wireless education is so important in the future. This is how it looks like. Basically, we have a mmWave dev kit. We have a UD kit, stands for up-down converter. So again, we have a mmWave, we have a frequency converter combined with a low-end SDR. Boom, that's solution for teaching. As you can see, the components are discrete, connected by cable. So it is very flexible yet powerful. This is one of a great example. The architecture diagram, when we put everything together, SDR, up-down converter again, and the beamformer. On the other side, we offer an omnidirectional mmWave antenna. We call it a COCO antenna, amplifier, up-down converter again, and the baseband, which is another SDR. Okay, so this setup is simple, but literally it's the fundamental of communications, right? Everything you need for a communication experiment are here. More important, not just hardware but software. Okay, we offer courseware. So as you can see, beamforming 101 or non-terrestrial IoT communication. Well, those have a good lab kit here. So your students and the professor, you can prepare the courses effortlessly. So finally, I will very quickly go through our design capability for our 5G, 6G, SATCOM, automotive, and defense phase array. Okay, now it's all about phase array. That's a category of phase array we ever built. We built phase array for 5G mmWave, for SATCOM ESA, for 60 gigahertz radar module. Even we built reconfigurable intelligence services. RIS is also one kind of phase array. We are very experienced in building different types of phase array to fulfill different applications. Most of them are customized, but we have our spatial technology, so we can, customize it for you and fulfill time to market. Okay, so here I was give those animation and phase applications here. Remember that ubiquitous network everywhere, 6G, the big vision. For all the segment, there's a role of phase array, not only on the payload, but also terminal or gateway, or even in HAPS, right? It's kind of drone. Fly over up to 20 km height. So different phase array type play with different baseband to fulfill different applications. So when we design ESA antenna, to give you an example, what's our consideration, right? We will consider how a tile-up structure can be beneficial to fulfill different orbit. We need to consider ultra-fast beam swap, because we need to track to do the handover for LEO, right? Or we use a dual beam architecture to perform handover, or we can even do the beam split, right? There's so many different considerations that we need to take into our account before we can customize the right thing, the right piece for you. Okay, so this is the final, the last slide that I'd like to show you. Those are the antennas we ever customized, design for different applications, including multi-orbit and even fixed beam SATCOM IoT solution, or HAPS gateway, and for ESA solution. All right, so thank you for listening. This is my presentation, and again, mmWave are a front-end company. Our expertise is great and matches to what a SAP is doing. So both company, we combine and offer the great solution for you, for education, for your wireless research, and even for your aerospace or SATCOM applications. Thank you for listening.
Move into the Q&A session. We have one questions related. So the first question is, how RIS configuration is computed. So we'd like to know how RIS configuration is computed. So if you can give us more details.
Yeah, sure. Sort of, it's about how how to configure. First, we provide an API, so you don't have to calculate the angle. You can just drag the GUI elements that you can basically drag the beam or to configure in the reflection angle. It's very easy. Or you are able to use the API. If you want to program by yourself, you can control the beam direction through API. And how those and our API will do the calculation for you, so you don't have to do the calculation by yourself. You just need to specify your angles. That's it.
Excellent. We have another question. What hardware and software tools are required to implement BBox or BBox 8x8 Duo in a lab or research setting?
All right. So basically, our API or SDK, we do support multiple engineering language. I think basically it supports Python, MATLAB, LabVIEW, C#, C++, and so on. So one of the engineer language you prefer, you can use it to control our device.
Perfect. I think related to MATLAB, so we have a question. Can we integrate RIS with MATLAB? And how simple is it?
Now, basically, how our API works is that basically you will need to download a middleware from our website, and then you just load some DLL into MATLAB, and you can start programming because we provide the examples. Yep, it's very straightforward for engineers. If you have any question, of course, our FAE is gonna help.
Excellent. If you still have any question, please feel free to write it down now so we can answer it immediately.
Okay, I saw there are a question from the chat. So the flat
Okay.
panel antenna for SATCOM, which band they are providing? Yep, we provide a KU band. There are some KA band project is ongoing, so it depends on your applications, and your the application will totally help us to define how we can design the phase array for you. So KU, my short answer is both KU and KA. That's for sure.
Okay, so Dr. Rahim he has a question related to the API, which are used to control RIS. Are these tools used as open source codes for students to be able to modify? Can we access them?
For RIS, basically all our API, you can find the the user guide from GitHub. So for that part, it is not open source, but we open API, so you can use that as you want. So the open source part is in our OAI platform. So that means the open air interface platform, all the protocol stack that you're using, that's open source. So you can use under some license as you want. Yeah.
Excellent. Do you have still any question that you would like to ask for the audience, from the audience? Feel free, we still have few minutes left. So we are here to answer all your questions. Also, please feel free to reach out to me so we can have a further discussion or have a visit to your facility anytime and discuss all your needs. So we can wait for 1 more minutes before closing.
Yeah, sure. So any questions? So we are eager to learn your applications, and if you have any idea, don't be hesitate. Just contact Michael or TMI Tech. So we can talk about what you need. Yeah.
Okay, excellent. I think there is no more questions. So I would like to thank everybody. I would like to have a special thanks to TMI Tech team for collaborating in this successful event. And it will be part of a series of events that we are planning to make in the future. Also along with on-site event and on-site visits that we will be doing jointly in the Middle East and specifically in Saudi Arabia and the Gulf region together. So we want you to be successful in your R&D projects, specifically in the wireless communication research. Also, you will all receive an email at the end with a short survey to request feedback about the event, and in case you have further questions related to the solutions, we are ready to answer anytime. So please take 5 minutes to go through it, and it will be very helpful for us to improve our future events. Thank you all for your time, and we will keep in touch.
Keep in touch, and thank you for
Thank you
listening
all.
today. Thank you.
And before closing, yes, Dr. Rahim, we will send you the recording of the session. The session will be available, so we will be sharing it with the faculty and all people, and also on our social media and YouTube channel. The presentation will be available. Thank you all for your time, and we will keep in touch. Bye bye.
Thank you. Bye.